No, that sounded all too well.
Okie dokie, we shall make a start. Yeah, so yeah, if everybody can make sure they're on mute for a minute, that would be cool. Just as we're talking, everybody's got the power. Right, let's jump in.
Hi everyone, my name is Matthew Patenka and I'm a cloud solution architect from Oxford.
Hey everybody, my name is John Lunn, aka Johnny Chips, and I'm a technical architect and I work for BT Enterprise in the UK.
My name is Ahmed Laja and I'm a cloud solution architect at Microsoft.
Hi, I'm Alan Kelly. I'm a cloud solution architect at Microsoft.
Hi, my name is George Washir. I work for the Intellectual Property Office as a senior engineer for the end user services.
I'm Richard Griffiths, and I'm the Cloud Solutions Architect at Confused.com.
Hi, I'm Adam Kaya. I work as a technical payment specialist for Clearlink.
So there we go. Hello, everybody, and welcome to the October meetup of the Welsh Azure user group. Yeah, thanks everybody for joining. Usual thing, just a quick hello from the team here, the organisation team at the Welsh Azure user group. We've got all our details there on the screen. It's a local community event. Obviously, we've just been having a chat around how we're starting to get back to a little bit of face-to-face. We had our first face-to-face meetup last month, so it was cool to meet some of you folk out there. So yeah, if you're there and you're on virtually now again today, thanks for joining. We are hoping to arrange these meetups, stay with the monthly cadence in terms of virtual, but then once a quarter run an in-person event. So by that rationale, our next in-person event should be the 15th of December. So yeah, we're just going to work out what we need to do for that. But yeah, it's great to have you all on. It's your event. If there's something you want to see, you want to reach out to any one of us, there's our details on the screen there. We all organise this group, yeah, for cool meetups like this. So moving on to tonight, we have yeah, two awesome speakers for you. We've got John and Derek coming on, so we're going to be talking about breaking up monolithic websites using Azure, and then Derek's going to come on and talk to us around Azure vWAN and that zero to hero kind of style. From a timings point of view, you normally get the little preamble from myself, just going through a little bit of housekeeping and saying hello to all you lovely folk out there, and we will kick off with John in 5 or 10 minutes or so. Don't forget, as per usual, we do have our Kahoot quiz. So if you've not used Kahoot before, give it a search on your mobile device, or you can use it through a browser. I think it's kahoot.com. After Derek's session, we will put the entry code up on the screen. You can tap the code in and join in. There are a couple of £25 Amazon vouchers up for grabs, so always worth joining in. And if it's anything to go by, Matt Fatunk has been doing the quiz, and he's been getting, well, he's turned into a bit of a quiz master, I think it's fair to say. They've been quite comical, so yeah, stay tuned for that. Yeah, and as always, we like your feedback, so we'll stick up a QR code after the event a little bit later on. We'd love you to just stick around and give us some feedback. That would be awesome. Yeah, as per usual, housekeeping rules. Please, everybody, be courteous to each other. You've all got control of your own mics, and you know, you mute your cameras. You know, be courteous. Stay on mute if you can. Give the speaker the time and the space that they need. If they call you off mute to answer a question or anything like that, please do so. But listen to what the speaker has got to say. There's no stupid questions. There's absolutely no silly questions. You've got access to chat. During the talks, if you want to put your question in chat at an appropriate point, we'll have a chat with the speaker and call that out and hopefully get that answered for you. And yeah, so like I say, download the Kahoot app and leave us some feedback at the end. And as always, these events can never really take place without the support of some sponsorship towards the group, and we have some amazing sponsors, at which point I'm going to hand you over to Des as our first sponsor and servant. So Des, yeah, if you want to say hello for 5.
Thanks, John. Appreciate it. Hi, everyone. For anybody who doesn't know me,
My name is Des Maguire. I'm a bit of an Azure veteran. I've been working with the platform for over 11 years. I'm also the founder and Azure Solution Director at Servant. We're an expert Azure partner. Although we're based in Glasgow, we work all over the UK with some of the largest enterprise customers. And yeah, we're really proud to sponsor the Welsh Azure User Group, the Northern Azure User Group, and we've got some guys on tonight from the Northern one and our home user group in Glasgow as well. And it wouldn't be me without having a little pitch to say that we are always actively recruiting, keen to hear from people from an apps infrastructure and data background who maybe want to further their career in Azure, some bleeding edge projects, or maybe people who want to move into Azure. So we're happy to speak to people from any background, whether it's just infrastructure, want to get a career into Azure, we can certainly help support that. And if it's guys that are more experienced on the platform, hit me up on LinkedIn or on Twitter. I'm on both, and I would really welcome a conversation with you. Other than that, thanks again, as always, John. Really proud to sponsor the Welsh User Group and see where it's grown to just now, and hopefully everyone you enjoy the rest of the evening. Thanks, John. Back to you.
Yeah, thanks, Des. No, really appreciate it. Like I say, it's always great to have these events sponsored by great companies like of Servant. We're fortunate enough to be sponsored by two other awesome companies in the fact that we've got locally HQ'd company Admiral, so Admiral Insurance, based down in Cardiff here. Great support from those guys as well, and of course we've got a third sponsor of NetApp. So like I say, huge shout out to those guys. Thanks so much for putting the time and effort and the support that they've all put into this community group. It helps us bring you prizes, bring you awesome speakers, and when we get out and about a little bit more on face to face, it pays for the pizza and beer that I know we enjoyed thoroughly last month. So yeah, only a quick one-off announcement now. Of course, for those of you who don't know, we've got the virtual Ignite session starting up in a couple of weeks. So the 2nd to the 4th of November. I thought I'd call it out on here. If you've not registered to the event, it's free registration. It is all virtual for this November event. Browse on over to that myignite.microsoft.com site, get yourself registered. Always some cool things going on there, and they always do the Cloud Skills Challenge. So if you look out for the Cloud Skills Challenge, you can get yourself kind of free Microsoft exam vouchers as well off the back of doing a few Learn modules, which of course is great because you learn some cool stuff as well. So go and check that out. So I think without further ado, we'll just crack on with the night. Like I say, everybody, thanks so much for joining in tonight. I can see a few new faces in there. Please feel free to reach out to myself, anybody else in the group, if you've got any ideas or thoughts or feelings about it. Great to see you. Take part in the chat now. Ask any questions. But on that note, I think I'm going to hand over to John. So, John, over to you.
Great. Thank you. Let me share my screen one moment. So, there we go. Great. So hopefully you can see that.
Yep, got it there, John. That's great.
Great. So I'm going to speak about breaking up monolithic websites with Azure. Firstly, thanks for having me. I think it's a great opportunity to share some of my experiences with you. The talk itself is going to be a mixture, actually, of software engineering processes, people and teams, and of course, Azure and infrastructure, which is something we'll look at towards the middle to end of the presentation. But before we get started, just a quick introduction to myself. So I'm a principal software architect. I work at PureGym, and I've been using Azure for 6 years now. I'm a certified Azure Solutions Architect. I blog at blueboxes.co.uk, and if you've got any questions after this session today, you can always find me on Twitter at John Kilmister. So if you've got any questions throughout the talk, do feel free to put them into the chat. I have got the chat window up here, and I'll keep an eye on that throughout. But there should also be some time at the end of the talk to catch up on any questions that we may have missed. So what are we going to cover in this talk? Well, the first thing we're going to talk about is the software monolith. If you've not worked with custom-built software before or haven't encountered it, we'll go through what the software monolith is and some of the potential challenges that software engineers might face. We'll then look at load balancers and routing, having a look at what a load balancer is and having a look at the Azure options for that and how it can help us solve some of those challenges that we might see with a monolith. And then at the end, we'll hopefully get a bit of time to have a look at some additional Azure services that we can put in place to help our software teams solve the problems that a monolith might have. So before we get too far, we have to first of all understand, well, what is a monolith? Well, some of you might remember this back from 2016. This is a monolith that was dropped into the Utah desert. And you might wonder, well, why are we looking at this? Because we were going to talk about software monoliths and Azure. Well, this represents what a monolith is, a single solid block. The definition normally refers to a block of stone or a block of other material, but it's the same thing when we're talking about software. It's one solid block. All layers of the application, so the front end, the back end APIs, all of the tests, everything is all coded together, all stored in one Git repo, and then it's managed and it's deployed all as one giant block. Now, is this a good or a bad thing? Well, actually, some people say software monolith and it has a lot of negative connotations, but actually it can be quite a positive choice. And it is a choice. And it's about choosing, do you build a monolith or do you build microservices and other architectures? And they're good when you've got a small team. You've only got a small number of people contributing to it. The code base is relatively small. You don't have to worry about all the connections between different components. You're deploying it to a single piece of infrastructure, so you haven't got lots of different things that could go down or different things to monitor. However, on the flip side, monoliths can easily get out of control and they can become large. And when we start getting a large team working on a large monolith, we end up in some challenges. They can often be referred to as, oh, it's the big ball of mud that is our monolith, or spaghetti code. In some ways, though, monoliths are very natural, and we'll have a look at that a bit later on. Let's take an example now of a website monolith. So we have an e-commerce website here. It has 3 simple features. It has product page listings, it has a shopping cart, and it has a checkout process. And we hired 3 engineers to work on this product. All's well and good. We ship it out to Azure every time a feature comes along. But over time, things start to get a bit slower and nobody can really understand why. So we go and hire a load more engineers because more people are going to solve the problem. They can develop more things and therefore we can deliver more features. However, they're all contributing to this single monolith and we can still only ship it at once because we've only got one code base and one set of infrastructure. And we add extra features and they don't really fit, but we try and squeeze them in and things slow down even more. And so the management decide we're going to add more engineers to the mix. And we're just piling on engineers who are doing more features and building more features. But it's now hard to find where to put these features in and where to squish them in. And then even once the features are ready, we still only have one set of infrastructure to ship these to. So a lot of the advantages that we had of a monolith when we were small, that we knew where the code was, there was only one bit of infrastructure to deploy to, have now become the thing that holds us back and holds the software team from delivering more features in a quick time. So in summary, the problems of a monolithic application at scale is you quickly get an unmanageable code base. You have a lack of ownership. So you've got one giant team that kind of owns everything and owns nothing. So if a bug appears in the checkout page, which engineer do you go to? Who picks up that code? And you all kind of work between yourselves to work out who was the last person to work on it. We have a high cognitive load. So that's really just how much can fit in your brain. Nobody can know the entirety of a large monolith. So every time you kind of pick up a new piece of work, you have to kind of relearn it and you get this high cognitive load. More relevant probably for this talk is that we get all or nothing scalability. So we've built out our website, our e-commerce site. It's got a shopping cart, it's got product pages, but we now also have a blog and a help center and lots of various bits and pieces. And we've scaled this up a little bit because we're getting more traffic to the site. But what if we run a promotion and we push everybody to a single product page? Or we decide to promote one of our blog articles. Well, because it's all part of the monolith, you have to scale everything, which could be really costly, rather than just scaling, say, the blog or just scaling a particular product page. Finally, we get deploy congestion. So we saw back in the last example, we had a large software team. They were working on a large code base, but they could only ship once because we shipped the entire monolith. And you make one minor change to that monolith, and you have to run your thousands of unit tests and integration tests before you can deploy it. And you've got two options. You can either all get in a queue and deploy one feature at a time, which is nice and safe. If something breaks, you know what's wrong. But the problem with this is that there's only so many hours in the day. And if it takes half an hour to deploy your monolith, and realistically it might take multiple hours, you can quickly only do 6-7 deploys a day. And if you've got 20-40 engineers, you're going to get this deploy congestion. Your alternative approach is to deploy everything at once. So save all your feature changes up and do a deploy once every week or 2 weeks. But now we've got a different challenge. When something goes wrong, and it's more likely to go wrong with more changes, how are you going to unpick it and work out what the change is? And you have to roll everything back. So we get this deploy congestion. You either have a queue or you bundle everything together. So we need to solve these problems. But if we don't solve these problems, what will happen? Well, things start to slow down. I like this graphic. I haven't got the original source, but this was a tweet that shared it. And you start off with a large code base, a monolith, and you get that brain overflow or that high cognitive load. And once you get that, you then have silos. So small parts of the department start to know about small parts of the system. And you quickly fall into elephant traps and things start failing and breaking, at which point you end up with Gantt charts and kind of, okay, well, things keep breaking and failing. We need to project manage this more. And development slows down, and then customers leave and engineers leave. And, well, you hire worse engineers because you can't get the best engineers to work on this giant system. And the code gets more tangled and complicated because you don't have engineers that necessarily understand the system. And eventually, depending on your scenario, the product potentially could get canned. This is maybe an over-exaggeration, but it's the kind of stuff that does happen, and if we don't tackle this problem. So how do we overcome these challenges? It all sounds a bit doom and gloom. Well, this monolith is unlikely to have happened overnight. You don't sit down and plan to build a giant monolith. You tend to start with a monolith with the intention of breaking it up, but things come along, you end up having new engineers, it's easier to slot something into what you've already got rather than address the challenges early on. So we're probably at a stage where we're 5 or 10 or maybe even 15 years down the road, and we've now got this giant product. But the way to overcome it is to break up the system. We want to break this system up so that it becomes manageable, so that we have independently scalable units, we have independently owned units, and things are small enough to work on, and we don't have a lot of those challenges. That solution actually is made up of 3 core parts: the people and the organization, the software, obviously, because we're talking about a software monolith, but quite importantly, the infrastructure, and in this case, our Azure infrastructure, can really give us a leg up here and support the efforts needed. So no one group of people can do this alone. If you don't work with the people and the organizational structure, you'll be fighting against it. If you don't have the software changes, you're not going to move forward. But as I mentioned, the infrastructure is a key part, and that's what we'll spend the rest of this talk on after we've just had a quick look at the people, team, and software elements. So the people. You might think, well, we've got engineers, we just want them to work differently, to work with our new broken up system. Well, you can try it, but often you'll find yourself fighting against it. If you have one team, you're going to end up with one monolith. If you have a software team for the front end and a software team for the back end, with all the best will in the world, you're probably going to end up with two monoliths, a back end and a front end monolith. So we need to kind of think about this again. And there's something called Conway's Law, that an organization's systems are designed so they mirror the communication structure. And this doesn't necessarily just apply to software engineering, it also applies to various other parts of the organization as well. So to put that into context, if we have an organization where you have one large team of developers, you'll end up with one large system. Even if you intend to break it up, it's easier, more natural to just put it into the thing you've already got. We don't have to ask our ops team for extra infrastructure if we just add it into the monolith. We don't have to worry about additional infrastructure as code or additional tests if we just take what we've got and we put it there. But if we split our team up and have modular teams that own parts of the system, then they're going to want to own their own parts of the system. So in turn, you end up with a software system or an infrastructure system that is more modular. And the communication between the teams will start to be mirrored in the communication between the parts of the system. Now, that's not what this talk is kind of focused on. We're going to have a look at the Azure infrastructure, as I said. So if this is something that interests you more, I would definitely recommend reading the Team Topologies book by Matthew Skelton. And in that, he talks about the 4 fundamental topologies. So you end up with different team types. So ones that are stream aligned to business units, product teams that align to product teams in the business, enabling teams, subsystem teams, and platform teams. And I've actually got a case study on the Team Topologies website where I talk through my experiences with a colleague of mine at my current company. I'd also like to point you in the direction of the Accelerate book, which talks about building and scaling high-performance technology teams. Both really good reads, and feel free to ask me more questions about that at the end. But going back to our second point, the software. So we've got this monolith and we know we want to break it up. How do we go about doing that? Well, we could just start the whole thing again. And a lot of software engineers quite like this idea. They're fed up of working on this monolith, never being able to ship anything. It's a big frustration. So why not just knock the whole thing down and start again? Well, if we use the analogy of a city, if you've got a part of the city that needs regeneration, rarely do you ask the whole community to move out for 5 years. You knock the whole city down, you rebuild it, and then you ask people to come back. And in the world of software, it's very similar. It would be really hard to justify going to the management team and saying, you know, this thing we've been building over the last 10 years, we'd like to, put it to one side and build it all fresh from the ground. And they go, well, how long is that going to take? And it's like, well, it took 10 years to build it in the first place, but with a bit extra work, we probably could do it in a year or two, or maybe a bit less. And during that time, you're not going to get any new features. And during that time, you're going to have to have a bit of disruption in the wider organization, and we're going to have to look at things. That is really unlikely to get buy-in. And if it does get buy-in, then throughout the project, if things start slipping or things don't quite work out, it soon goes back, well, we'll just continue to use the monolith. So how do we get over this problem? We've got a large monolith. We know it needs breaking up. We know it's the right thing to do in our circumstances because we've got such a large team. Well, we take it one slice at a time. And much like this cake, although it might feel like a great idea to eat it all in one go, my experience, much like breaking up monoliths, has taught me that's probably not the best idea. And it's definitely more palatable to take it one slice at a time. And you can then take it at a pace that works for you. And in the case of the monolith, your organization. And if you decide to take a bit of a break, that's perfectly fine. But one slice at a time is much more manageable. And that's really where the story of infrastructure comes in. And it's through using Azure's infrastructure that we can allow our software teams to start breaking up this monolith bit by bit. So the second part is going to talk about routing and load balancers. We're going to go a bit of theory first, and then we'll dive into Azure. So with a load balancer, we have two fundamental types. In this diagram, we've got a user, they hit a website, and then we're using a load balancer to equally distribute the traffic between three databases. And this is what we call a layer 4 load balancer, working at the transport layer. And what it's doing is it's just taking the packets, TCP, UDP packets, and just distributing them equally between those three servers. And this type of load balancer isn't particularly intelligent, it's just distributing the network packets. A second load balancer, and in this case I've slotted it in between the user and the websites, is what we call a layer 7 load balancer. And this type of load balancer can actually look inside those packets and actually intelligently route based on information that comes in. So it could be routing based on a website URL or a HTTP header or any other data that's coming from the website. So these layer 7 load balancers are a lot more intelligent. While we're on the theory side of things, I do just want to point out that this is also an internal load balancer because it's not public facing, it sits inside our network. And Azure has loads of these throughout the system, mainly transparent to yourself. If you have an Azure web app that's scaled to 4 instances, behind the scenes, there'll be an internal load balancer distributing the traffic out. And then the other type is a public load balancer. And either can be layer 4 or layer 7, but the public load balancer is hit directly by the end user. So let's flip back now to our monolith, and this is our monolith. The user comes and hits the website, and in that website that's deployed, it's got the user interface, it's got all the APIs, it's got the whole website, and that's talking to a backend database. So the first thing we can do to split this up is take our backend and split it up. And there's lots of techniques for doing this, but essentially you take the different domains, break them apart, and create separate projects for it. And this is starting to help us. We now have smaller deployable units, and there's less to worry about. And microservices is quite a well-known pattern. And for the user, it hasn't affected them because they're still hitting the same website, they're still getting the same experience. We're just pointing different parts of that website to the different parts of the back end. But we still have a challenge because whatever happens, any changes in that back end, people still have to work with our front end website, which is still a monolith. So how can we fix that? Well, we could do this. We could break it up into separate websites. And how are you going to get to those websites? Well, we could use DNS. So create products, shopping, checkout, all the subdomains. And some websites do this. You'll see that in the URL. But as I mentioned, this monolith has been around for a very long time now, maybe 5-10 years. We can't just go change all the URLs. We'd need to put in redirects. We would lose any links. That we had in emails. We would confuse users and all the SEO benefit we've built up over these years. So what can we do instead? We still want to break up the front end, but we want the user to have the nice seamless experience. And this is where our layer 7 load balancer comes in. So if they go to our website /products, internally we can route them to a product page website, or if they go /cart, it can go to a shopping cart website. However, to them, it seems like one seamless experience. We now have really clear vertical slices. And those vertical slices mean that we no longer have an unmanageable code base. We don't have a high cognitive load because people can specialize in one of these areas. Maybe you've got a team that looks after the product pages and the product API in a vertical slice. We don't have deploy congestion either, because you can deploy them independently. You can scale them independently. And we now know which team to go to for each slice because a team will own the product pages. If there's a problem with it, you can go to that team. So that's the theory. What are our options to help us in Azure? Well, Azure offers 4 load balancing and routing options. Traffic Manager, Azure Load Balancer, Application Gateway, and Azure Front Door. We're going to quickly go through these and see how we can, if or how we can use them. The first one is Traffic Manager, and Traffic Manager isn't a load balancer but a routing option. The user hits that, it picks a server and returns an IP address which the user's navigated to, and that means you can route by priority or weighted or performance, but because it's DNS based, it won't look inside the packet, so it doesn't give us that layer 7 routing. Our second option is Azure Load Balancer, and this is a layer 4 load balancer, so it's going to work at TCP and UDP protocols. And because of that, our routing options really are all based around a hashing algorithm that it uses. You can use session affinity, so people go back to the same server, but it's not going to solve our problem here. So the third option is Azure Application Gateway, and this is working at the layer 7, and it works with HTTP and HTTPS. But most importantly is the routing options include URLs and various other things that we can determine from those packets. However, the application gateway is regional. It sits inside an Azure region, which means if you want high availability or you want disaster recovery scenarios, because it's in one region and it routes to traffic in that region, if you lose a region, you've lost your website. So for most large websites, this isn't what you want. You can pair it with Traffic Manager, so have one of these in each region and then have a Traffic Manager, which is global. However, a more appropriate solution is Azure Front Door. It's layer 7, so it works at HTTPS, it's global, and it has all the same routing options. So a quick review of that, and we can see there that Azure Front Door is really the only one that ticks the box of being both global and layer 7 routing. Take our application and we actually go about implementing it. How do we do that? Well, first of all, you hook up your monolithic application to your front door instance, and we just route all traffic to it. And at this point, it doesn't give us a huge benefit. There are some features that you gain in front door, and we'll have a look at those in a minute, but we haven't gained a huge amount. But what it does, it puts in place infrastructure for the future. And then we can start adding in rules. We can say anything that's blog / will actually be internally routed to a static website sitting in blob storage. And we can add in products and they can go to a static web app if you wanted. We also have the option of adding in multiple servers. So anything that goes to /cart will then be intelligently routed either to a Western Europe or a Northern Europe instance. So we can load balance inside one of these pools in addition to routing to them. And then we can route to the checkout. You get the idea. We can slowly pick off parts of this monolith. So over time, we can take parts out and we're not dependent on it. It means you can go at your own pace. It also means you can have this polyglot landscape of using different technologies in different places. If WordPress is the best thing for your blog, that's fine. You can have a C# ASP.NET website, but still have a WordPress blog if that's what you need. All under the same domain name and the same URL structure. And eventually what our aim is to do is to remove that monolith so we have a modern application. So what options are there when it comes to front door? Well, we have just Azure Front Door, and this is the original front door instances that they offered. And then we also have Front Door Standard in preview and Front Door Premium in preview. If we look at the features, we can see what you get in Premium that you don't get in Standard. So in addition to all the routing that we've just talked about, you also get things like secure origins with private links. Now, this means that these back-end servers can talk only to Front Door, and all the users have to go through Front Door to get them, and that prevents sideways attacks. We can do SSL offload, so we can terminate the SSL cert at Front Door, so we don't have to distribute our production public SSL to all of the back-end services. And it is worth noting at this point, you can actually have a fully managed SSL cert provided by Front Door as well. We get the web application firewall. You get a built-in CDN and compression, bot protection, basic DDoS protection, and it integrates with threat protection as well. We also have health probes, so we can monitor the servers in those individual pools to make sure they're available before we serve traffic to them. All of the features you see here in black are what you get with standard, and all of the blue features are the additional things you get with premium. Next, I want to have a look at how we actually go about configuring a front door, and we'll have a very quick look at a demo as well. So this is what the configuration looks like. You set up your front end domains, so your primary web addresses. You then set up your back end pools, and that's what we looked at as each of those applications, be it the cart or the product pages or whatever. You create a pool for each of those. And then most importantly, you create a routing rule that joins the two together. You say for this URL, redirect to this backend pool. If we flip over now to the preview version, so what we're here looking here is the main front door. The preview version is pretty much the same, but it is worth noting that some of the terminology has changed. We now have origin groups instead of pools, and we have domains instead of front-end hosts. You'll also see a fourth section called security, which brings the WAF and bot protection, DDoS protection right up front and center. Let's just flip across now and risk a demo. I will just change over to the other screen. And we will bring that up. Okay. So, and I will change camera so you can see me better. Right, so what we're looking at here. So I have an Azure web app inside the Azure portal. It's just a standard app service, and I've deployed a Docker container to this app service. And for the purposes of this, this is our monolith that we're going to send all default traffic to. As I said, this is just the ASP.NET demo Docker image. So it's got two pages, a home page, which gives you some stats, and a privacy policy. Now, we're going to have a look at how we're going to set a front door instance up in order to redirect this privacy policy to a new location. So if we jump back into here, and front door can be found by the normal menu. And as you can see here, we have front doors, and then we also have our standard and premium preview version of front doors, which we'll be using today. If we create a new one, just click create, and you get the standard slide out menu. There are a number of options here, but we're going to do a custom create so that we can go through all of the options. We need to choose a resource group, as you would with anything else. So I'm just going to put it in the static sample, and give our profile a name. So FD Demo 4. Okay, we choose if we want a standard or premium. As we saw, the premium one gives you additional security options, but you can change this later. As we move across, the endpoints. So the endpoint is our domain that we want to use. And initially, we have to create one that ends in azurefd.net. So we'll call this FD Demo 04. We get to add our own custom domains on after we've initially set it up. Right, now we get this screen that we were looking at before. So we can't add any custom domains at the moment. We can do that later on, but we will add our origin groups or our backend pools. So the first thing we want to do is add in kind of our default monolith. So I'm just going to put in an origin group called default. And now we add in the servers. So I'm just going to call this default site, and we select our origin type. And it has some ones already set up for you. So if we've got an app service, we can quickly select that and select our app service, which is the FD web app sample there. You can change the host header if you wish, but we're going to leave that. And you can also change the ports. Because this is a pool of servers, so we could add in multiple servers in different regions, you can set the priority and the weighting. But in our example, we're just going to add the one server in. Under here, we also get to set the health probes. So you set the URL to ping on a regular basis, and how we're actually going to do that. So as well as that URL, it's just going to be a head request that we're going to do, and the interval. What's important to know about this interval is that because front door is a global resource, if you leave this as a default, it will be hit every 100 seconds from hundreds of locations around the world. So you actually get quite a lot of traffic. So if you pick a path here that goes and hits the database or goes and requests a third-party system, you could find quite a lot of traffic going to that. With the load balancing options, we also get a few more options there about how it's going to route, how it's going to choose between all of the servers in this particular origin. Once we've added that, we then need to add in our rules. So in here, we're going to add in our default rule, and we're going to say which domains we want this to work for. So if you have got multiple domains set up, you have to go and tick all of the ones that you want to apply. And we select the path to match. And as this is the default, we're just going to leave it with /* so it just catches everything. And then we select our origin group, so our pool of servers we want to route to. So everything as the default is going to go to the default pool. And then from that, we can just add. We then want to add in our second origin group and our second rule, but we can't do that as part of setting up. So from that, we just click review and create, and we go to the review and create screen. I'm not going to create this at the moment here because it does take quite some time to set it up. So in good demo style, I have one I prepared earlier. So this is a demo one that I've already set up. And if we have a look at the endpoint manager, this gives us the same view. We can see our domain. We've got our original domain here that I set it up with, which was fd demo z01 front door. And if I copy that, I can quickly go to that, and we should see it all route successfully. And we can also see that I've attached it to demo.blueboxes.co.uk, which we can see here. We've got two host names for the same thing. We've got two origin groups now. So we've got this default site, which is set up exactly as, but I've also added in a privacy group. And this privacy site is just pointed to Azure static blob storage, sorry, and it's just got a HTML page in. Nothing special about that, as I said, I could have added more servers in. If we now go to the routes, we can see the privacy route here, and anything that's /privacy will now be directed to the origin group privacy site. So if we now go back to here for demo blue boxes, we can see if we click privacy, we actually end up at the privacy 2.0 policy. So if we go direct to the web app, we get privacy policy. If we go via front door, we actually get our main web page, and then we get privacy 2.0. It's worth noting these routing rules, it doesn't matter the order of them. It will pick the most suitable route, sort of the best match, should I say, and then forward across to that. You can also do extra things. So you can add rules. So here we've added a rule. So we've said we're going to have a mobile rule. And we say that if the device is equal to mobile, then we're going to add an extra HTTP header into it, and we're going to override the action group. So these rules allow us to add loads of extra conditions in. So we saw on the routes, we could only choose URL, but if we want to do a redirect based on something else, maybe a custom HTTP header or maybe a device that's coming in, you can come in here and we can add a condition based on all of these things, query strings, remote addresses, and all of that. And then we can add an action, which might be as simple as just adding in a cache expiry or a response header, but also we can override the origin group. And to see that in action, what I've done is in this demo is if I go back to the back to our origin groups, and we go back, sorry, not origin groups, endpoint manager. Go back to the endpoint manager, we look at our privacy route. Right at the bottom, you'll see here, I added a rule, a mobile rule. So I took the rule set that we created and attached it to this route. So when this route is run, this rule will also be run. And the rule set is called mobile rules. So what we should see is that if you come in on a mobile address, I don't know why it doesn't save that, it will add in an X-mobile header, just with the value of true, and it will still go back to the default site. So what we have here is our privacy policy, and we know that's going through front door because it's showing us 2.0. But if we bring open the console here, and we go to switch it into a mobile view, so we're now looking at it on an old Moto G4, refresh the page, and we see we've got privacy policy again, because it's picked up that it's a mobile device and it's not done it's redirected it to the default pool. And if we look at the networking and refresh the page, you'll be able to see where's the request? I didn't leave that on request. That's all skewed up. Here we go. So under privacy, we should be able to see under the headers that we've got X mobile is true. So it's added in an extra header, which the software engineers can then use to display the page differently or whatever. So you don't have to do any redirects in those rules. You can just put in extra headers to help the engineers. So that's the very quick demo. Front door does have lots of other options as well, and we can see these back on if we go back into here, on the left-hand side, you can set all the WAF and other bits and pieces. We can optimize it with CDNs, store secrets and various bits and pieces. But let's flip now back to our slides and have a quick look before we finish with the additional Azure services. So far, we've talked about splitting everything up and how great it is to be able to have vertical slices that can be owned and managed independently and everything else. But the reality is we want one website that looks the same. It's consistent across the website. And we don't want the user to even know that it's a different website. So how do we do that with shared configuration? We might have things like App Insights keys that we want to be the same on every web page. Well, we can store these in Azure App Configuration. Azure App Configuration is designed to be a central store of configuration, and it's a key value store. So you can put in there, put in a key, and we can request values from there. It's all versioned and everything else. But what if you've got a secret? Well, when we start splitting our monolith up, we might find that actually initially we can't split up our database. So we might need to, all of these little separate websites might all need to point back to a single website, single database. And we can't store our connection string inside Azure App Configuration. But we can pair it with Key Vault. So we can put our secret in Key Vault. Put it in Key Vault and use Key Vault references. Put the Key Vault reference back in the Azure App Configuration, and when the app requests the secret, it will then ask Key Vault, which will then return it back through. So Azure App Configuration is a really good way of still sharing some of these things between the sites. It also offers feature flags, which can be another benefit, because you've also got to think about the people maintaining these websites. They don't want to have to log into 6 different systems to change feature flags. They want one centralized way of changing feature flags. The other consideration is authentication and authorization. You don't want to have the end user to think it's one website and then have to log in 6 different times. So you need a central way of logging in. And there are third parties that will provide this service for you. However, Azure AD Enterprise Applications does give you some of that. And package management. I thought I'd finish with this. So a lot of you are probably aware of Azure DevOps and the fact that it can do package management, but this is a really important feature for software engineers. If you want to have a unit of code that is shared by lots of different applications, you can bundle it up into a package. And we're always using things like NPM packages or NuGet packages, but it's easy to build your own, and they can be hosted in Azure DevOps, and then we can pull them in at build time. So a very whistle-stop tour of those additional services, but I thought they were mentioning it. So let's just take a recap of what we've gone over today. We looked at software monoliths and the fact that this really just means that everything's developed together, noting that it's not always a bad thing. But when we start looking at scale, we have challenges around deploy congestion, scalability, lack of ownership. The solution really has to be in three parts: the people and the team, the code and the software, and the infrastructure. And it's the infrastructure that we went on to focus about. We talked how the aim is to split it into scalable, small vertical slices. But we want to keep the existing URLs, remembering SEO, single login, common look and feel. So we looked at load balancers and how these can route traffic, both layer 4, but more importantly for this solution, layer 7. And we saw how front door was the solution in our case to serve this. And based on the URL, we can go to different parts of the application. And then we quickly finished up at the end with other services. So if you want to learn more, if you're interested in the Teams aspect of it, I would definitely recommend checking out the team topologies. If you want to learn more about load balancing options, then have a look at the Microsoft Learn pages. There's an article on choosing the right load balancing solution. And if you're interested more in front door, there is an Azure Friday on the preview version of front door. Thank you for taking the time to listen to me. I've been John Kilmister, and as I mentioned before, you can find me at John Kilmister or at blueboxes.co.uk. Thank you.
Thanks very much, John. Awesome stuff. Really impressed with that talk. Thanks for taking the time and taking us through it, John. It was brilliant.
No problem.
So, yeah, I'm not sure if we've got any questions in the chat. Go ahead.
I haven't seen any there.
I don't know what's going on. Do people realise we've got a chat? There we go. We've got a quick question from Hugh.
Would you set up? What setup would you suggest for local development of a complete microservices architecture, or do you have to develop it in conjunction with Azure hosting? So you can use a Docker sort of a local Kubernetes cluster for this if you wanted locally. So I didn't talk about Kubernetes at all in this, but Kubernetes does have a load balancer, where you can choose your load balancer that sits in front of your applications. You could argue, well, why don't you just deploy that cluster into production? Well, it is regional, so you still really do need an Azure load balancer in front of that. So it's a little bit of a different topic. But typically, you don't spin the entire solution up. These individual vertical slices are owned by an individual team, and they would mock out the kind of interconnected bits. So if you want to go and link off to the checkout, for example, from the product pages, they would mock their own version of that and probably have a stub version that doesn't have all of that logic. So it's unlikely locally you'd want the entire solution spun up. But if you did, probably Docker and potentially Kubernetes if you want to put a load balancer in front of it. Hopefully that answers it.
Perfect. Thanks, John. There we go. Ross. Well, I'll leave you. The questions are coming through thick and fast now, John.
Have we got time to answer them, or?
Yeah, no, absolutely. Yeah.
Great. So I'll do separating a monolith with this approach probably requires that already to be a monolith on a good code level. Not necessarily, because I would say a good URL structure potentially, but you can take a really old legacy one and just say, I don't know, if they go to /help, it takes them to a completely separate website. So you don't need to share anything. You do have some challenges that if you want to make it look and feel the same, like the same CSS or the same like logging frameworks and things like that, you do have to work out that challenge. It's not necessarily simple, but no, you don't necessarily have to have a monolith that you can actually break apart. What we're doing is we're putting our monolith to one side and having a new route and a new website. Do you have challenges with configs? We try and reduce as much shared config as possible, but it is a challenge when you do have shared config, because if one person updates it, then you have to get everybody else to update it, unless you use something like Azure App Configuration. But ideally, each of the vertical slices has their own logins to any shared backend systems and has their own own set of configs, hopefully. The idea really is to create these vertical slices. And what about state between sites? That's a good point. With old websites, you may have used in-memory state. That's less used these days. But you can put your state in a shared database if you really want to, but probably want to avoid that. Otherwise, you've got local storage or cookies if you do need to move things between. So we'll use like a language cookie or a language hint cookie that will persist the language between the microsites. But we did all have to kind of agree that up front. Hopefully that answers all the questions quite quickly.
That was like another mini talk then, John, you know? Right. No, I think that's great. I don't think there's any more questions coming through the chat there, but yeah, John, thanks so much once again. If everybody wants to show their appreciation, either come off mute, use the nice little graphics. Yeah, thank you so much, John.
Thank you for having me.
Okie dokie, we shall move swiftly on, and we are going to hand over to Mr. Derek Smith. If you're there, Derek, to talk about Azure Virtual WAN. I can tell he's searching for his mute button, Derek, aren't you? You're there trying to find it.
Totally. I'm absolutely trying to find my mute button.
Over to you, matey.
Alrighty, let me bring up my PowerPoint. It doesn't like it. Do this the other way.
You doing all right, Derek, or is it just those bits coming over from the west coast of America? Just
No, I think it's just the bits coming over from the west coast of America.
Oh dear.
I know. Gotta love that. All right.
There we are. Got you.
Perfect. Alrighty. Well, greetings, everybody. My name is Derek Smith. I am a Azure Cloud Evangelist with a company here based in the States called Trace3. I have been working with Azure for just between 5 and 6 years now. Much like John before me, I do hold a number of Azure certifications within the platform around solution architecture, administration, security, and most recently the networking engineer certification. You guys can find me on Twitter at ConsiderCloudDS and then also on LinkedIn at the address there. And today we're just going to be chatting with probably one of the more hot topics within Azure networking, and that being Azure Virtual WAN. The reason why we consider connectivity, at least from a cloud perspective, to somewhat be a little bit messy these days is there are multiple connectivity options, whether it be ExpressRoute, site-to-site VPN, or point-to-site VPN. But their traditional implementations have certain limitations that don't lend itself well to enterprise scale. A lot of site-to-site VPN gateways cap out at 30 connections. You cannot have anything beyond that. Point-to-site VPN gateways cap out at about 10,000 user connections. And so given some of the hybrid work options that we've seen globally, that's been a huge limitation as a lot of companies shifted to people working remotely, or at least remote work on at least a 50-50 basis. So so these network virtual capabilities have been somewhat of a challenge from Microsoft's traditional networking capabilities. Operationally, there have been some challenges. A lot of the virtual network gateways have been contained within their operational interface. You don't have a good way of looking at your site-to-site VPN gateway next to your point-to-site VPN gateway, maybe even next to your express route gateway. There wasn't a good central way to view all connectivity options under a single banner. If you're an old network engineer, I think you've heard this probably 1,000 times. A lot of end users, when they experience application issues or certain hangups, it's always the network's fault. Blame the network is a constant thing. Even I still hear today that if something goes wrong, oh, it must be the network. And so we want to make sure that, as users deploy enterprise scale, we're looking to address some of those challenges. So not saying that this phrase will ever go away, but hopefully it comes out a little less out of people's thought process. And then also there's been this software-defined shift. A lot of organizations in today's world are now shifting to a more SD-WAN networking approach, both from an on-prem perspective, but also from a cloud perspective. And so how best do we help interconnect what a customer or a client is doing from an SD-WAN perspective into our cloud environment? And then finally, I think one of the absolute other biggest topics in the cloud world today is zero trust security. And so how best do we take our connectivity model and our networking to the cloud and implement zero trust policies? And all of that can be achieved through Azure Virtual WAN. Microsoft's original vision for this product was to bring together those three pillars, right? Networking, security, and routing under a SD-WAN as a service cloud-based offering, backed by their fiber backbone that is stretched throughout the world, one of the largest, next to a couple of other large providers. And so really under the Azure Virtual WAN, there are these 5 key areas that we can think of: connectivity, their global transit architecture, the secure virtual hub, routing, and then the newest one is integrating a network virtual appliance directly into the virtual hub. And we'll kind of talk about how all of these are weaved together and complement each other. So the first main pillar is connectivity. All of those previous connectivity options that we talked about, site-to-site VPN, point-to-site VPN, as well as ExpressRoute, are all under the same gateway, so to speak. Within your virtual hub, you can deploy a VPN gateway for either site-to-site or point-to-site or both. And then you also can deploy a ExpressRoute gateway. All of those gateways are housed within a single virtual hub instance. You do not have to spin up different instances to handle each of these connectivity models. They are all centralized in a single location for you. Now, there are some strategic partnerships as it relates to some of the connectivity models, and this lends itself to some of the SD-WAN as a service offerings that Microsoft has with Virtual WAN. So some of these names like Checkpoint, Palo Alto, Cisco, Zscaler, Barracuda, VMware, iBoss, all of these vendors have an automated capability of deploying their SD-WAN solution directly with Azure Virtual WAN. And there are multiple other partners that you can do this with as well. I just didn't have a big enough slide to include all of them, but you have the ability not only to take a customer's existing SD-WAN as a service offering. I'll use, say, Palo Alto as an example. If I have multiple Palo Alto firewalls deployed at all of my various branch locations and even data centers, and they're all connected using Palo Alto's SD-WAN offering, I can then actually go and pivot into my Azure cloud using the Palo Alto SD-WAN offering and combine it with my Azure Virtual WAN. And as I add maybe potentially new branch locations, I can automatically onboard those locations into my Azure Virtual WAN with Palo Alto's SD-WAN offering. Now, how are we able to do this within Azure Virtual WAN? The biggest thing is obviously Microsoft's global transit architecture. This global transit architecture allows you to set up a fully meshed hub-to-hub environment. So think of a hub as a Azure region. So there are about 67, 69 Azure regions today. So each virtual hub can be deployed in one Azure region. It is a one-to-one relationship. So as I deploy a hub, say here in the States in East US 2, I can then deploy another hub, say over in UK South. And those two hubs are automatically meshed together behind Microsoft's global transit backbone. So this any-to-any connectivity model allows me to connect my branch to Azure. I can go from my branch to another branch. I can connect my mobile users to a branch location. And it also allows VNet to VNet transitive capabilities. So Virtual WAN is an automatic hub and spoke architecture congruent with the enterprise scale landing zone architecture that Microsoft highlights that a lot of customers adopt. And then also you can transit between your express route and your VPN connections for redundancy capabilities. Now, how Microsoft is able to do this within Azure Virtual WAN is the Virtual Hub Router. This is the same type of router that you can now get with the route server option. So I know that's one of the latest and greatest technologies that Microsoft has rolled out. That technology is exactly based on what they have learned doing Azure Virtual WAN. So that Virtual Hub Router is deployed, one router per virtual hub. It controls all of the routing between the 3 gateways within the virtual hub, so your point to site, your site to site, as well as your express route gateway. It also provides the virtual network transitive routing capability. So as I need to transit between one VNet to another, I use that router as my ability to get from one VNet to another. Now this router has a 50 gigabit throughput limit per region. However, there's one little hiccup in there in that for every hub that I deploy within my virtual WAN, I have to subtract from the overall 500 virtual networks that I can connect in my virtual WAN environment. So say I have 6 hubs or 6 regions that I'm deployed in, my maximum amount of VNets that I'm allowed to connect is 494. Now, within that virtual hub, you also have the ability to create custom routing. This routing is actually very different from the traditional user-defined routes that we're used to from a normal Azure perspective. These custom route tables are specific to the virtual networks only. They do not apply to any of the virtual network gateways that are deployed within the virtual hub. Those route tables, for better or for worse, hopefully will eventually be applied to the gateways, but for now, there's only the default route table, which applies to what Microsoft defines as the branches, which are your gateways, and then your custom routes are applied directly to this virtual network. Now, those route tables can take on one of 2 methodologies. You associate those route tables to your various VNet connections to learn routes from. And then on the flip side, you can also take the routes that are on those virtual network connections and propagate them into the route tables for somewhat of a dynamic routing capability. Now, from a security perspective, Microsoft recently, within the last 12 months, added the ability to secure the virtual hub with a security device. You can either choose the Azure Firewall or the Azure Premium Firewall, whichever SKU fits your fancy, or you can leverage one of their security as a service partners. Zscaler, iBoss, and Checkpoint are currently the only 3 that are supported today within the Azure Virtual WAN environment. Other vendors will be onboarded on later dates. So make sure if you have a preferred vendor that you would like to use to check with them and see when they might be adopting Azure Firewall as one of their offerings. The reason why these 4 technologies are the only ones supported today is their ability to integrate with the Azure Firewall Manager. The Azure Firewall Manager is what really allows the virtual hub to operate in a multi-region environment where you can create and deploy policies across multiple firewalls or multiple regions. You can secure internet-bound traffic this specific route is from your VNet to the internet or branch to internet. Currently today, there is a limitation between secure virtual hub to secure virtual hub. You cannot actually inspect the traffic that travels between the two. This is something that Microsoft is working on and hopefully will have rectified in a later release of the secure virtual hub. And finally, the last part of Azure Virtual WAN is this new capability to integrate a network virtual appliance. From a traditional network virtual appliance perspective, we've been used to deploying these devices behind the virtual WAN and having to connect them in a traditional VNet configuration manner. However, Microsoft has now brought on 2 different partners to integrate their NVAs directly into the virtual hub itself. These 2 partners are Barracuda and Cisco Viptela. Now, what this capability allows you to do is it allows you to support not only the transitive scenario, so as between site-to-site VPN to remote user to ExpressRoute, but it also gives you the ability to support all of that provider's proprietary features. So if you have certain features within Viptela or Barracuda that you really enjoy using from an SD-WAN perspective, those features are available to you directly in that integrated situation. Now, behind the scenes, there's built-in resiliency within the Azure Virtual Hub, so there's no need for you to set up a availability set or deploy the NVAs in an availability zone setup because Microsoft's already taking care of that for you behind the scenes. So putting it all together, the virtual WAN provides both connectivity and security with ExpressRoute, point-to-site VPN, and site-to-site VPN, as well as VNet connection alongside providing security with the Azure Firewall or one of the security service partners. The ExpressRoute gateway scales to up to 20 gigabits per second aggregate throughput. So it is highly designed for ExpressRoutes of 1 to 2 gig, but if you're looking at ExpressRoutes, say, of 10 to 20, virtual WAN may not be your particular network connectivity model of choice. The user or point-to-site VPN can scale up to 100,000 users, which is about 200 gigabits of aggregate throughput, ideal for our current situation within the pandemic where a lot of people are remote or working from home. Virtual WAN was an ideal solution to enable enterprises and organizations to onboard a multitude of users quickly and efficiently to allow them access to their not only cloud environment, but also their on-prem environment to access applications and resources. Additionally, your site-to-site VPN gateway within Virtual Hub can scale up to 1,000 branches or remote site connections with a 20 gigabit aggregate throughput capability. And then as we talked about before, virtual network to virtual network routing is supported. Remember, 500 VNet connections is the limit. However, you need to subtract the number of hubs that you have. Now, what makes Virtual WAN unique is these distinct features. You have your firewall manager partners. So again, iBoss, Zscaler, and Checkpoint, as well as others to be added at a later date, natively integrate with the Azure Secure Virtual Hub. You have your site-to-site connectivity automation with your SD-WAN partners. So if you have a preferred SD-WAN solution, more than likely that partner will integrate directly with Azure Virtual WAN, automating your site-to-site connection setup with your Azure Virtual WAN instance with your branch location. The point-to-site VPN gateway actually has a built-in traffic manager that you do not see or control, but this allows the users to be automatically routed to their closest region, reducing the number of hops and latency that they need to access their environment. And then the ExpressRoute has a site-to-site VPN encryption capability that you can set up over the ExpressRoute tunnel. Remember, the hubs are fully meshed, so once you spin up a hub, they do automatically connect to one another. But if they are secure virtual hubs, remember that traffic cannot be inspected at present time between the two secure virtual hubs. A number of traffic patterns are supported, whether it be ExpressRoute to VNet express route to site-to-site, site-to-site to point-to-site, VNet to VNet, or even point-to-site out to the internet. One thing to note about virtual WAN, when you are looking to deploy this for yourself or for your client, there are a number of cost considerations to take into consideration. You need to take into consideration your throughput or scale unit. So each gateway has a certain scale unit, and that's based on the aggregate throughput you expect to come through the gateway. Each gateway has its own unit of increment, so do make sure that as you're sizing out your gateway, that you size accordingly. And then there's also the number of connections that you might have for VPN and ExpressRoute. If you do deploy a secure virtual hub, standard firewall charges do apply. So do make sure you take that into consideration when designing this solution. Hub to hub is only charged based on your egress charges only, not ingress charges. Now, one of the more difficult things within Azure Virtual WAN is the routing capabilities of the virtual WAN itself. Spinning up a virtual network gateway or an express route gateway or a point-to-site gateway is really no different from the traditional ones that we are used to. So where I see a lot of customers and other Azure professionals struggle with virtual WAN as it comes to the routing, and that's because it is not the same as a user-defined routing. So I figured we'd dive in a little deeper into how different routing scenarios might work in a typical customer environment. Now, by default, virtual WAN is built to be an any-to-any connectivity model. So that means any location can route to any other location, so whether that be a branch location or a connected virtual network. Now, connections learn routes from their associated route table. And remember that this is specific to those custom route tables that might apply to your virtual network. So you can see here that a default route table can be applied to not only the virtual network connections, but it also applies to all of your branch connections. Now, additionally, you can propagate routes into the route table itself. So if you would want your connections to learn routes from other connections, you would select the option to propagate those routes directly into that route table, giving it a more dynamic routing feature as you would expect from an on-prem routing situation. So in our any-to-any use case scenario, you'll see that the default route table has all of the routing connections from each of the branch, as well as the two VNets, because we are propagating all of the routes into a single route table, and that single route table is associated to every connection. Now, our first situation is what if we do want to have a custom route table instead of using the default any-to-any route table situation? You can actually create your own route table. In this example, we created one called RT_VNet, and we're going to apply this virtual network route table to our two virtual networks. Now, we're not going to do anything fancy. We're just going to give it an association to VNet 1 and VNet 2, as well as VNet 3. Now, you can see here on VNet 3, I'm giving it a supernet of the on-prem location. And that's because I don't necessarily need to call out anything specific to my branch location because there's no need for VNet 3 to have a more specific route. Now, I can add a static route into a custom route table if I so choose. That is handled in the exact same way that you would in a user-defined route table. I would go ahead and set up the virtual network connection as my learned route, and then I would actually configure that specific virtual network connection to use a static hop, much like I would do in a user-defined route. So I can define a next hop as another virtual network gateway or a specific network virtual appliance, maybe an IP in front of a load balancer. So it's all handled in the same manner as you would from a user-defined route perspective if I want to actually add in a static route instead of a dynamic one. Now, another common use case is maybe your customer or client wants to isolate a virtual network. So in this example, we'll isolate virtual network 1 from virtual network 2. Now, our branch locations will still be able to reach both virtual networks, but maybe for regulatory reasons or security reasons, I don't want any lateral movement between my two virtual networks. So my default route table, again, which is associated to my on-prem locations, would have my branch location route, but then I would create an additional custom route table for my virtual network. So I would populate my site-to-site as well as my express route, and I'd also populate my virtual networks. Now on my custom route table, I would only add the routes for my branch locations, and I would be very specific about adding my site-to-site VPN as well as my express route. I wouldn't do a supernet like I would in the previous example. And with this routing setup, we essentially effectively isolate VNet 1 from VNet 2 because the route table associated with each of those connections only knows how to get to my on-prem locations. It does not know how to route to my other virtual network. Now, another common scenario would be, what if I have a shared service VNet? So we'll bring back our trusty VNet 3, and this will act as our shared services virtual network. And in this example, we'll still keep our default route table. Again, that's always going to be associated with our branch locations. We will add in our VNet 3 connection ID, as well as our other two virtual network connections. And then we'll apply a custom route table to our virtual networks, add in our branch location. Now, in this particular instance, though, what we're going to do is we're going to add in that static route for our shared services VNet. So 10.3.0.5 will essentially function as our network virtual appliance or our gateway into our shared services VNet. I then want to broaden another common use case. What if I've got multiple virtual networks across multiple regions and I need to isolate specific VNets from each other? So we're going to add in another region. Now remember, these hubs are automatically connected. And I want to make sure that only my orange VNets can talk to each other and only my blue VNets can talk to each other. So in this instance, I'll have my default route table. And in this particular case, we're going to add in this concept of labels. Labels are going to define how we can add routes into distinct route tables. Now, while this is still within the same virtual WAN instance, our label is what allows us to populate routes into a specific defined label, in this instance, default. And because the default route table carries the default label automatically, that's how we can span two default route tables with the same branch connections. So as you can see here, all of my branch locations are added on both route tables because of that label. Additionally, I'm going to create two custom route tables, one with a label of blue, the other one with a label of orange. And the reason behind this is I only want my orange VNet talking to my orange VNet and my blue talking to my blue. So the label orange and the label blue allows me to populate route specific for my blue VNet and route specific for my orange VNet. Now, obviously by default, we're going to make sure that both labels get our on-prem location. However, for blue, I'm only going to add VNet 1 and VNet 3. And then in orange, I'm only going to add VNet 2 and VNet 4. Now, this effectively isolates the virtual networks from each other. They can only see the other label. So VNet 2 can only see VNet 4 and vice versa. Same with VNet 1 and VNet 3. And then our branch locations will get all 4 VNet connections. Now, multi-hub does work with any-to-any. That is another common use case as well. However, we only need our single route table and our single label. But because it is a multi-hub scenario, we do want to make sure that we are populating default with all of our connections so that we can then apply it to the other default table that's created with the other virtual hub in the other region. And finally, the last common use case is let's add in that Azure firewall and secure the virtual hub. Now, by default, we want to make sure that all of our traffic, because we are not trusting anything and we want to inspect everything, we're actually going to add in a very specific route to our default route tables, and that's the quad 0 route. And we want to specify that the next hop is the Azure firewall. This effectively forces all traffic, whether you're on-prem or in Azure, to go out the Azure firewall for security purposes. None of the hub-to-hub traffic is inspected. Again, a current limitation, but all traffic from VNet 3 and VNet 4, as well as the on-prem, are inspected as they head out the internet, or if they transit down to the branch or the virtual network. Now, this is becoming a less common use case as routing through a network virtual appliance that might sit behind a virtual hub, but I do still see it deploy out there in some customer environments. It functions the same way as if I were routing through a shared services virtual network. However, what you might see from a routing situation is some other VNets attached to that specific virtual network. So in this use case, we've added 2 more virtual networks attached to VNet 2 and VNet 4. And so in this routing scenario, how would you actually route from on-prem all the way to, say, VNet 2A or VNet 2B? Now, the key here is you would specify on your VNet 2 connection route that you have a static entry. That static entry being whatever the load balancer or NBA IP is. So in our cases, we have 10.2.0.5 and 10.4.0.5. Now, unfortunately, the virtual WAN routing does not extend to these indirect spokes. So you will have to use user-defined routes to make sure that routing is connected to your VNet that is connected. And then once you have those UDRs in place, again, we'll put in that static route on the VNet 2 connection, as well as the VNet 4 connection. And then once that is added, you'll enter that NBA IP, and I'll be able to route directly from an on-prem location right into one of the indirect spokes. I wanted to go through kind of how you would set up a custom route table within the portal before we get to our demo. So as you can see in here, I have a snapshot of a portal example here. I would go up to the top within my virtual hub and select create a route table. Now this little graphical window will pop up asking you some basic information. The name needs to just be unique within your virtual WAN instance. It doesn't need to be globally unique. So I just named mine test route table. And you can see here, just right down below, I can automatically start adding routes that I want this route table to be responsible for and where their next hop destination is. The 2 options that you can choose are either your VNet connection ID or Azure Firewall if you have a secure virtual hub deployed. Remember that a label can be set up to propagate routes across multiple route tables. So if I'm in a multi-hub scenario within my virtual WAN instance, do make sure that you create a label if you want routes to be propagated across multiple route tables. Remember again, when I get to my association page, an association is a connection that will learn routes from the route table that you are creating. So if I want to associate my custom route table with any number of virtual networks. Remember that that virtual network will learn routes from the routes that are within this route table. And then finally, you'll select your propagation. You can choose to propagate from any location that you want. So if you want to propagate into this route table from your branch locations or from other virtual networks, you are welcome to do so. The route table will dynamically learn all of those routes based on the propagation settings that you select. Once you're done creating your route table, you can go ahead and double check your work. So you can actually go into a section within routing called effective routes, choose your created route table, and then see all of the effective routes that are available for that specific route table, what their next hop is, and where they're coming from. If you do set up BGP, the AS path information will be also available to you within that route table. So just to summarize in routing, remember, site-to-site, point-to-site, and express route connections are all considered branch. That is a limitation within virtual WAN today. The product team is aware that most folks would like this to be separated out and are working on a feature update for this. Custom route tables at present can only support being connected to virtual networks. Remember, associating a route table to a connection means they learn routes from that route table. Propagating routes to a route table means that they learn routes from that connection. Same routing preference is true within Azure as it is within Azure Virtual WAN. The more specific route always wins. Make sure when you do set up an Azure firewall within your virtual hub to make sure that you set up a static route as the next hop for that quad 0. And any additional static routes, your only options are either the VNet connection or Azure firewall. Always make sure you check your effective routes for the route tables that you create to make sure that the routing is doing as the design that you put forth. It's a great troubleshooting feature to go ahead and look at those route tables and view their effective routes before you actually go into deployment. Now, one connection label I did not talk about is called the none label, and that is created by default. The reason being is I rarely see this used in production by any client, but just so that you're aware of it, essentially that label of none and the none route table means that's a black hole. So if you do not want a connection learning any routes, you would just want to completely isolate it from the rest of your virtual environment. Choose none as your option, and it will not learn any routes, and it will not route to anything within your virtual WAN environment. Next steps. I highly encourage everybody to go and spin up your own Azure Virtual WAN LUT. There's a very useful GitHub demo with the address that I've provided here. There are ARM templates and bicep templates within this code repository. So whichever is your flavor of choosing, whether you want to use ARM template or bicep, you can go ahead and use those templates. Action item number 2, if you want to learn more about Azure Virtual WAN, there are a couple of different learning path options. You can go to the Azure Solution Architect AZ303 before it gets deprecated out. There are a number of virtual WAN learning path options available in that particular exam path, or the more deeper path is with the AZ700. Because of its networking focus, Azure Virtual WAN is a prominent topic within that learning path. And just to summarize, Azure Virtual WAN does provide a ubiquitous connectivity, routing, and security, all within a unified framework. And with that, we are going to flip over to my demo. If it's even done being deployed. So finding virtual WAN within the Azure portal is pretty easy. You just type in Azure Virtual WAN. And you'll find it right down here. You just look for the cloud with the little purple routing icon. Creating one is pretty easy, whether you do it via the portal or a templatized environment. You just need to select a resource group where that resource group is located. It will automatically choose the resource group location. You'll just give it a name. There are two types of SKUs within Azure Virtual WAN, basic and standard. Basic only supports site-to-site VPN, so it's great for proof of concepts or proof of values or just labbing it in, at home. Standard is the fully featured SKU item, so you'll get point-to-site VPN, express route, as well as some of the more advanced routing capabilities within Virtual WAN. So depending on what you would like to lab or test at home, just be mindful of that. You can upgrade your SKU from basic to standard. However, once you upgrade to standard, that's it. You cannot go back. So if you need to go back down to basic, you'll just need to blow away your virtual WAN and create a new one. Now, obviously, in good demo fashion, I already have a virtual WAN set up in my environment. Within the virtual WAN, you get a nice little overview of some of the various items. You can see here that I do have one hub deployed. At the moment, its current status is failed, which is obviously awesome. So we'll go and check and see what's going on with that particular hub in just a minute. But as you can see here, I have branch-to-branch enabled. I only have one virtual hub deployed. I can view my network topology within this environment just by clicking this little icon. I'll go right into the updated network insights capabilities within Azure, and it'll kind of give you that same network topology. I'm not going to lie, they used to have a global picture of all the virtual hubs of which regions you were deployed in. I do like that map a little better, but this one's nice for diagram purposes. Within your settings configuration, if you do need to do that upgrade, that's where you would upgrade that SKU. It's right here. As you can see, mine's grayed out because I'm already on the standard. You can actually disable branch-to-branch connectivity if you so choose. So if you do not want your various branches talking to each other, you can actually disable that capability, though most customers tend to leave it enabled because they do want their branch and other type of connections to reach each other. Now, as you can see here, I do have one hub. It's currently in a failed state. So if that is the case, and I see that this gateway hub is actually in a failed state, I actually do have two options to kind of help get that hub up and running. There's the reset router option as well as the reset hub option. Essentially what each of these options do is redeploy the router for reset router, and then reset hub redeploys the hub as well as any gateways you might have deployed in this environment. You can check your current health status of your hub as well as your router. As you can see here, both of mine are green. So I'm guessing my VPN gateway just might have a little bit of an issue establishing its site-to-site VPN connection. So I can actually drill into this here further. As you can see here, my virtual network gateway only has one scale unit, 500 megabits, because it is just a demo. I don't need anything higher. But you do see that there is an X2 next to this, and that's because the virtual network gateway is active by default. So you do have two instances of the gateway that you can connect to at any given time. Each of them do have their own unique private IPs as well as public IPs. So when you are setting up your VPN connections, for a high availability standpoint, I do highly recommend connecting to both instances of the virtual network gateway. In case one does go down, you do have an alternative route to get back to your virtual WAN gateway. You can see that I do have the options for an express route or user VPN. I didn't spin up any of those gateways just because mocking up an express route is rather difficult in the demo environment, and user VPN is no different from that perspective. Now I can go into the routing capabilities here that we discussed earlier, and you'll see a very familiar screen. So you'll see that I have my default route table, the none route table, and then I have my custom routing table called RTVNet. Now I can view the effective routes of those route tables. So we can choose my default route table. And it'll load up all of the routes that are associated with this route table. As you can see, because I'm not currently associated with any, because my VPN connection is currently having some issues, there's no routes here. However, if I choose my RTVNet, we should actually see a couple of routes pop up. Or maybe not. That's only because I have my two firewall route tables. But for an example, live environment. So I have my route of 2 firewall. Notice it's that quad 0. And then my next hop is my specific Azure firewall. Notice I'm not choosing my spoke VPN connection. Now, if I did want to add in a static route, I would choose my VNet connection. And then right here next to that, if I want to configure that static option, I would just hit the configure button, and I can add in that next hop specific IP for static routing. If I want to view any of my virtual network connections, you can choose that option right here under your connectivity blade. I can see all of the associated VNet connections I might have with my particular virtual WAN instance. As you can see here, I just have one connection. When you do go to associate your various virtual network connections, you can pick which hub you want to associate it to, so it's not hub specific. You choose that hub as you're setting up that particular virtual network connection. Now, when you do set up the VNet connection, you can choose to enable your routing out of the gate. However, I find it as a best practice when I set up my client environment to add in my associated route tables after I've added my VNet connection. And then finally, within the virtual WAN, you do have the ability to monitor your various connections. So you can configure connection monitor within virtual WAN itself. So I can set up a resource VM connection from somewhere in one of my virtual networks and test it to, say, maybe an on-prem location or maybe even another cloud location. It really doesn't matter from that perspective. And I can set up as many connection monitors as I want within the virtual WAN environment. And then additionally, I also have access, again, to that Monitor Insights capability. You do not have to go to Azure Monitor to view this information. It's built in directly into virtual WAN. So as a network engineer, if I need to troubleshoot my virtual WAN instance, I can go directly into virtual WAN and take a look at any one of my connections and see what's going on. As you can see here, it tells me that my virtual network gateway is having an issue and that it failed to deploy. So I could go directly into that particular resource and see what the issue is. And then I have the option to reset that gateway to hopefully get it redeployed and have it functioning in an operational manner. And that does it. That is Azure Virtual WAN.
Thanks so much, Derek. I think we've got a question in the chat there. I don't know if you can access the chat or you want me to read it out.
I can.
Yeah. I think it's just along the lines of Sebastian's asking any reasons why one should stick to the self-managed hub and spoke architecture. So, you know, the traditional hub and spoke where we manage our own gateways, UDRs, and the firewall. Is it much more expensive than the traditional architecture, the hub and spoke architecture?
To be honest, it's not much more expensive. You just get the advantage of true enterprise scale with Azure Virtual WAN versus the traditional hub and spoke architecture. What I see clients typically do from their perspective, right? If you know you're going to connect more than 30 branch locations, or you need a way to kind of aggregate your express route connections from multiple HQ or data center locations, or you need the scale of point to site, that tends to be why people go with virtual WAN. More lately, it's just been the simplicity of it. From an operational standpoint, it's much easier for a customer's cloud engineer or a cloud admin to go into one place to look at all of the various networking options, depending on what they have enabled, and manage the networking and routing from that perspective, than to have to go into an individual gateway or go into multiple various UDRs and try and track down what might be going wrong or what they might need to update from a routing perspective. So just the overall operational overhead tends to be a lot less. Virtual WAN, yes, is going to be a tad bit more expensive from a traditional hub and spoke architecture. But I think you typically make a case for efficiency and less time spending on certain issues with virtual WAN that end up, I think, outweighing those cost benefit ratios from my perspective. So when I typically recommend customers to go into Azure Virtual WAN and they get into the environment and start actually using it, they don't go back because they like the ease of use and the simplicity it gives them versus having to manage multiple resources across multiple different regions, and it becomes somewhat of a headache from their perspective.
No, good stuff. No, appreciate that. No, thanks so much, Derek. I don't think we've got any more questions there in the chat now, but no, thank you very much. Really appreciate that talk. Learned a lot there myself as well, so all good stuff from my point of view. Yeah, everybody, if you want to come off mute, show your support and appreciation. Thank you, Derek Smith.
Thank you. Appreciate you guys having me.
Fine. Thanks, Derek. Okie dokie. So it's quiz time, everybody. We've made it through two awesome speakers. You know, I hope you'll agree they've been fantastic tonight. So whilst I don't know, Matt, are you taking over, or Ahmed, are you going to run with the quiz?
I'm here. I made it.
You got out of your meeting.
My training, yeah. There we go.
Matt, is this quiz as good as they've been the last few months?
It's on form. I hope so, anyway.
Cool. Over to you then, buddy.
Thank you very much. Right. So, what we got in here? How many people we got in? Good turnout tonight.
Yeah. I think we pushed into the 30 mark, which is good. People still want these virtual sessions, which is awesome.
I thought everyone would be quizzed out from the South Coast Summit the weekend, wasn't it?
You can see the pub quiz there of the evening. I'm joining them on this one.
Yeah, you haven't seen it yet either. Yeah. I'll be up to.
We go for the win.
Right, there are a couple of the evil ones again. Just thought I'd let everyone know it was there last time. Right, we'll give it another minute or so, a couple of seconds. Anyone else looking to join?
Yeah. I'm going to say, is anybody struggling to get on? We normally have one or two last-minute stragglers, don't we?
16, it's good. I think any more, otherwise I'll start it off.
Anyone? Yeah, I think we're good then.
Let's give it a go. Okay. Got the right quiz, that's a good start. Easy ones to start with. Which Microsoft event is scheduled for the 2nd to the 4th of November? Is it Explode, Build, Ignite, or KubeCon? Oh, I see everyone knew that one. That's good. Right then. Ross with the fast fingers again. Type the answer. You know you love these. Know the Azure product. Name the Azure product, should I say. A lot of stump faces on cameras. That's what I like to see. Have we got any answers? Any answers coming in? API management. Somebody got it. API management. Come on.
I thought that was a not a shredded wheat. What's the other one? Weetabix. Thinking.
There you go. Just to see it. Just so that you can review. API. Come on, it was genius. There's another couple of them, so I hope you're ready for them. And Ross is the only one. Well done, mate. Which GitHub event takes place between October 27th and 28th? Galaxy, Universe, Red Dwarf, or Black Hole? It's GitHub Universe. Yep, next week. Should be a good one to tune into. Oh, there's no stopping him tonight. Dean in second place. Visual Studio 2022 launches on what date? Is it November 8th, November 1st, January 1st, or December 12th? Can you tell I've had a dev week this week? There's lots of dev questions coming up. It's November 8th. 10 of you knew that one. Guess you didn't get that one then, Dean. It's a puzzle. Order the programming languages from first appearance, oldest first. So you're going to have to drag and drop those around on your screen.
Don't forget the submit button as well.
Yeah. Good call. I put that one for slightly too long. Has everyone answered? There we go. So the correct order is Python, Java, C#, and Rust. Rust being the newbie amongst all those. No score on that one. It's a bit weird.
No, Matt.
Don't know what's going on with Coot there. Type the answer. Come on then. Name the Azure feature. We've got some answers coming in. That's a good sign. Not completely stumped everyone this time. There we go. Managed identity. And I even gave you identities or identity. There we go.
What was the clown about, sorry?
It's it. Stephen King's It. Managed ident, it, E.
Fine.
Oh, we've lost Ross from the top. William Shatner became the oldest man to go into space. How old was he? 75, 85, 90, or 95? And there's some debate as to whether or not he went into space. He was 90. Oh, that split the pack a bit. John still sticking up there. Another quiz. How big was the DDoS attack that Azure mitigated in August? Was it a terabit a second, a gigabit, 5 gigabit a second, 725 gigabit a second, or 2.4 terabits per second? We beat the previous record by 1 or 0.1, should I say, which probably gives it away. Well done, 2.4 terabits per second. AWS had the previous record at 2.3 terabits per second, which is a massive amount of traffic to be mitigating. Colin leaps the lead. Type the answer, name the Azure product. Easy one, this one. Answers are coming in now, that's good. Last one, last second. It was, of course, IoT Edge.
IoT Internet Explorer didn't fit.
It's not Internet Explorer, that one. I had to use a different logo for that one. 9 of you got that. Colin stays on top. Couple more questions to go. How much will the Xbox mini fridge cost when it goes on sale in the US in December? Which is a beautiful little product. And actually the pre-orders went up today and were gone completely. Scalpers got it apparently, so unless you're looking on eBay if you want to buy one now. And the answer was $99.99. And there's a beautiful video out there of them fitting an Xbox Series X directly inside an Xbox mini fridge, because it's exactly the right size. Oh, Joe with a surge to second. Penultimate question. Microsoft Jackie Wright tops the list of the most powerful Black Britons. What's her job title? So there was, I think it was a Times article or a Guardian article about influential Black people. And this lady topped it. She's an amazing lady as well. And she is our Chief Digital Officer. So that split the pack a bit as well. Only 4 of you on there. That's going to shaking things up. Joe with the surge right at the last minute. Microsoft recently acquired OKR startup Ally.io. What does OKR stand for? Is it Ocelots, Kangaroos and Rabbits? Only Kings Rule? Objectives and Key Results? Or Open Key Retrospectives? There we go. Most of you got that one. Objectives and Key Results. And no, I don't know what that means either. So let's have a look at the podium. In 3rd place, John K. Well done, John. Colin B takes 2nd. And in a late surge, our winner tonight is Joe. Well done, Joe.
Are we doing
Thanks, guys.
First and second? Matt?
Yep, I think that's a good plan.
So Joe and Colin B, drop me your email addresses if you can over DM, Twitter, whatever it might be, LinkedIn, anything. I'll get a £25 Amazon voucher out to each of you. Cheers, Matt. Brilliant as always. Right, let's go into the closing throws. Yeah, well done, guys, and thanks for taking part, everybody. Right, let me just flash up the last couple of slides then to close out the evening. Okie dokie. So yeah, absolutely. Thanks, huge thanks to both John and Derek for, I hope everybody will agree to awesome talks there this evening. Yeah, appreciate you coming on, giving up your time to impart your knowledge over to us. So thanks so much, guys. And on to our next virtual event is save the date, 17th of November. We've got Mark Allen coming on to talk to us around real world Azure static web apps, and David O'Brien coming on to talk to us about building a cloud security SaaS startup on Azure. So a bit more dev focused talks next month, so save the date. And our good friends from the Northern Azure user group have got their first in-person meetup, as you heard Des mention earlier on. So go and give those guys some support if you can, if you're in and around the area. Michael, are you still on, or Joe? Is it whereabouts you having it?
Yeah, we're still here. It's going to be in the centre of Manchester, just at the Robert Walters office, which is near Spinningfields. So it's pretty central to for traffic links and stuff like that. But just like yourself, we're going to be streaming it as well, so you can join on Teams if you can't make it there.
Awesome. Yeah, no, absolutely. So jump on the links on there, but go and follow the guys over at on Twitter, Northern Azure UG. But yeah, thanks both. Okay, that brings us to the closing throws of this evening. Yeah, if you can, scan that QR code. Leave us some feedback. Let us know what you liked, what you didn't like, what you know, if you want to be a speaker, absolutely fill in your details on that form and let us know. We shall absolutely reach out to you. But yeah, if you can leave us the feedback, it just goes to say thanks everybody for joining. Have a great rest of your evening, and we will see you all next month. Cheers, everyone.
Thanks, everyone.
Thank you.
Cheers, bye.
Bye.
Bye.